Welcome to the Big BIM webinar sponsored by the Workflow 4.0 e-newsletter and ClearEdge 3D. Our webinar topic today is Big BIM, Managing Very Large As-Built BIM Projects. My name is Kevin Corbley, and I'll be your moderator today. I'm the editor-in-chief of Workflow 4.0. That's the newsletter of 3D scanning, modeling, documentation, ideas, and opinions. And first, let me start by thanking you, our attendees, for joining us today. Today's webinar is big in all respects. We have almost 500 people registered, so we know the Big BIM topic is an important one to you. And today we will focus on the unique challenges of very large as-built BIM projects. And to be specific, what we mean by big is projects that involve multiple buildings or structures over a large area, such as you might find at a medical facility or a university campus. And you'll hear some real-life case studies in just a few minutes. Let's take a quick look at today's agenda. After my short introduction here, we're going to talk about the Big BIM projects. First, we'll hear about a multi-building modeling project at University of Sheffield in the United Kingdom. And then we'll learn about a new construction project involving several buildings at a major healthcare facility in the United States. And finally, ClearEdge 3D's Alex Dimogenes will offer Big BIM insights that he's rounded up from experts around the country. And of course, we'll wrap up with Ask the Experts. That's where we answer questions from all of our attendees. And a few quick housekeeping details. Everyone is muted. Everyone in the audience, of course, is muted except for the presenters. And feel free to ask questions. Now, you can do that by typing them into the chat box, which you should find in the lower right corner of your screen. And we're going to wait till the end to take Q&A during that session for about the last 15 minutes. And just a reminder, the webinar is being recorded, and you'll each receive a link by email if you'd like to watch again or even share that with your colleagues. We encourage you to do so. And we also encourage you to subscribe to the Workflow 4.0 newsletter. And as I said, that's a newsletter for learning as well as sharing experiences, opinions, and best practices. Now, let me take a minute to introduce our panelists today. First, we've got Phil Tapp. He's the BIM manager at Berry Associates, located in Worcester, England. And Phil has quite a bit of experience in building 3D models using Revit. And after Phil, we're going to be hearing from Siavash Mohseni. He's the virtual design construction lead engineer for Hensel Phelps, one of the largest construction companies in the United States. And Siavash has about a decade of experience working on what he calls and we call mega projects. And many of you already know Alex Dimogenes. He's the North American Sales Director for ClearEdge 3D. Alex is extremely knowledgeable in all things laser scanning, and most notably, as some of you remember him as a Faro account manager. Gentlemen, we're happy to have you with us today. And let's talk goals and perspectives. As BIM technology has become more accepted in the AEC workflow, it's being applied in larger and more complex projects. And however, bigger projects, that means greater risk, as poor planning and execution can cause much bigger problems down the road. And that's really the perspective we'll be starting off from today as we visit with our presenters. And so our overall goal today is to provide you with a checklist of essential project management tactics that you can use to lessen the risk in your next Big BIM project. All right, so first I'd like to bring on Phil Tapp from Berry Associates to get us started. And Phil, welcome to the webinar. And go ahead, take it away.
Hi there, everyone. My name's Phil Tapp. I'm the BIM manager here at Berry Associates. I'll give you a bit of a background on Berry Associates and myself. I've been with the company since 2007, and we've been providing surveys as Revit models since 2007. And we've been providing survey to BIM. And I say survey to BIM rather than scan to BIM because what we provide is a sort of all-round service, not an automated system of just straight from scan data, but encompassing all survey techniques and getting into an existing BIM building. So our sort of background is a mixture of topographical surveys, measured building surveys, and that's the range of experience that we've gained over the years, and we take that across into our Revit and BIM services. So we've built up over the years a pretty large portfolio of survey to BIM, survey to Revit models, topographical surveys to Revit, underground surveys to Revit, highly detailed architectural models of maybe sort of heritage facades, full structural models, full MEP models, sort of buildings of all ages, everything from modern to sort of classic older buildings, sort of typically Victorian and early 20th century. And this includes the sort of building we're going to talk about today. And we work across many sectors, you name it, we scan it, everything from education, health, commercial properties, public buildings, residential properties. We're a company that's based in the UK, sort of central UK, but we've got a strategic partnership with a company called 3D Virtual Design Technology, and they're based in the San Francisco Bay Area. So we're working with them on several projects at the moment. Okay, so the project I'm going to talk about today is a project we carried out in the north of England, at the University of Sheffield, and it's called Heartspace. And although on the larger side, it's a pretty typical project for us. And I'm going to go through the sort of basic methodology of how we approach the project. I'll mention some of the issues we faced, talk about the deliverable, and give a few sort of tips and tricks about handling the projects of this size. So you've got a few sort of facts and figures up in front of you, but initially we were approached by university's design team and asked to produce a detailed Revit model showing all architectural detail, structure, MEP, and full topography around the area. So the team needed a Revit file, but more importantly, they needed an IFC file for translation into ArchiCAD, because the ArchiCAD package was the main package they were using for the design. So they needed an IFC plus 2D drawings as well. So we were at a bit of an advantage with this project in the fact that we'd already carried out some survey work on the site, a topographical survey, and some building survey, all in 2D, but we had in place a good, strong control network. So I'll give you a little bit of background of the sort of proposed plans for the project. So as you can see, you've got a bit of an overview of the buildings in front of you on the image. And the proposed plans were for some amount of refurb within the buildings, but the more major plan was to build a roof canopy, a glazed roof canopy, which would span between a number of the buildings, basically creating a usable courtyard space, making the most of the courtyard space. And this was to be a kind of very modern organic structure which would maintain the architectural sort of merit of the facades of the buildings while creating a usable sort of modern space for the university. So I'm sure you can imagine this threw up a sort of few challenges, a few unique challenges, and you can tell from this image in front that access and visibility for the roof was a major part of that. And actually for this project, we invested in a Faro X330 specifically for the project. On previous projects, we would have hired maybe a Leica C10, but for this project, for the sort of more fluid workflow to fit in with our systems using our Faro 120s, we purchased an X330, and it was invaluable. So on top of this, the roof access issue, we also had the fact that the building was in use as a university, so you had a mixture of rooms such as lecture theatres and laboratories with existing experiments. So these had their access limitations, but also that a big part of the project was the MEP, and a lot of the structure and MEP was found above false ceiling tiles in the rooms. So this provided an access issue both physically in terms of the height, but also in terms of issues to do with asbestos. And so our surveyors needed qualifications and protective clothing, etc., to allow them to access this. So again, more access issues. I've mentioned their IFC deliverable, and I think I'll come back to that a little bit later and talk about that. So I'll talk a bit about field data collection, and I think for a project of this size, it's absolutely essential that it's planned well in advance, and it's planned to split the project down into manageable chunks, so that you don't overwhelm the site surveyors, both the site surveyors and the office technicians, with too much data all at once. Keep it manageable, yeah, so that it doesn't overwhelm them. Basically, it keeps everything fresh in their mind while they're working on it. And an obvious statement is to say good clean data and good survey control, but I think even more essential on a building this size, a project this size, as we're talking about big distances, and those errors can increase very easily. But again, we're at a bit of an advantage on this project because we'd carried out survey work before, so we knew our control was tight. So another advantage we had was that previously we'd left up self-adhesive targets, so the Faro checkerboard targets, and this meant that we could tie in pretty quickly and easily and accurately back into areas of survey, so that it all tied in very, very closely. So a couple of tips on a project this size, and pretty much any project really. The first is to always use scan location sketches. This helps in efficiency, both in registration of your data, but also in terms of any technician that needs to access that data very quickly. They've got a reference to it, and you'll save a huge amount of time if you've got these sketches and plans. The second is to have a gopher, to have somebody who will run ahead and arrange your access so that your limitations in access don't impede your workflow, basically your on-site workflow. So in total, we had around 1,500 scans, and about 300 of those were above false ceilings, and this was to collect that huge amount of MEP data that was so crucial. So we had about 3 scanners on site per day, 80 scans per day, and you can imagine this increases our amount of data we take home pretty quickly. We kept our numbers down to about 3 days at a time. This meant that it was more manageable in terms of taking that data back to the office. I think it's fairly crucial that those surveyors are able to register that data while it's fresh in their mind, so they don't get overwhelmed with it. So, as I've mentioned, register as you go. Make sure there's not too much work coming back to the office all at once. But maybe an obvious point, but actually to keep enough space on your server, on your hard drives in the office, because on a project this size, it's amazing how much data you can rack up pretty quick. When you include duplicates of all of the point clouds from your raw point clouds, your registered point clouds, your duplicates for a different file format to get into Revit, maybe formats for Edgewise, you need to import CAD, import images into your project, and all your backups you might need as well. I mean, on this project, we had about 3 terabytes of data before we cleaned the project up. And so this throws up issues with network speed and computing power. And so our server here is pretty powerful, and all our machines are pretty high-end, really, to cope with this data. So on average on this project, we had around 3 members working constantly, collaboratively, but with also a dedicated member of staff using Edgewise to extract that MEP. Over such a huge site, it was crucial to have that in an efficient way. Okay, so Edgewise. We use this Edgewise on this project purely for MEP extraction. It's just because the nature of the site, the nature of the building, and the specific project requirements from the client, the building extraction wasn't so suitable. But the MEP extraction was just invaluable, really. And over around 20–25% of the site, I would say, we used this. And we used it in mostly the dense areas, because extracting that data very quickly was just so much faster than manually doing it. We may have had some areas where we've used, the inbuilt MEP modeling tools within Revit, but I think as a tool in our armory, it was really advantageous to have it. And in these dense areas, we would estimate it increased our efficiency by about 70%. So an overview of the sort of final deliverable. That's the whole model put together, and you can kind of see the level of detail we've gone into externally, at least. So we've shown, you can see the full fenestration on all the windows. You can see all the pipework, and quite importantly, all the roof detail, all the eave level detail, because this was pretty essential for their roof plans. Okay, there's a side view of the final deliverable, and I'm hopefully going to play a clip now just to give you a bit of an overview of the whole project. Okay. Okay. After the next slide, oh, sorry about that. Okay, so here we are. I'll see if I can show you a clip. Okay, so this video, hopefully you can see this. It kind of shows you here the level of detail we've gone into externally. You can see all the fenestration on the windows, the mullion detail, and more importantly, the courtyard side rather than the front facade. So here's a kind of idea of how comprehensive the survey was internally. Absolutely everything included. We've included 4 topographical areas with inspection covers shown. We're showing, again, you can see all the stonework, the detail work, eave level detail, and again, all the project-specific window families we've had to create. So in a moment, we're going to go internally for a bit of a glimpse of a typical internal area with some MEP. There we are. And then this is a typical laboratory kind of area. So we've got some equipment kind of blocked out generically, but it gives you a general idea of a standard room with some MEP and some structure within it across this site. And there's an overview. Okay, I'll just pass it back up to the main webinar. Sorry, Kevin, if you could take control back to the webinar.
Okay, great. And you have a couple more slides, don't you, Phil?
Yeah, thank you. Okay, so for the final deliverable, the two key areas was for the architect. The first was to have the final deliverable as an IFC, as they were working in ArchiCAD, like I mentioned earlier. And it was really crucial because our IFC should be a universal format for translating this data from any BIM package to another BIM package. But there's always a few little issues that get thrown up in different projects. And specifically for ArchiCAD, one of the issues we had to deal with was that it was very important for us because ArchiCAD handles the geometry per story. So for this project, we wouldn't usually have to do this with Revit, but for this project, we had to separate all the geometry, such as walls, columns, anything spanning any story, into, per floor, basically. So we had to change our workflow very slightly there. And also, although model size isn't too difficult for us, as we're used to handling this kind of level of data, with point clouds and everything all linked in, actually, as an end user, the architect wanted the model as a usable, workable size. So we actually had to split the project up into 3 areas to keep it manageable. Sorry, Kevin, I don't seem to have control of the slide.
There you go.
Thank you. Okay, so a few final kind of tips and tactics for keeping your efficiency up on a survey to BIM project like this. Basically, I think the main one is to work closely with the client. I think in a new part of the industry as we are now, clients are looking for very different things from their BIM survey to BIM projects. Some clients working to level 3 BIM where they need absolutely everything included. And some clients are looking for more of a 3D conceptual design where they might be doing most of their work from 2D drawings still. So I think it's pretty crucial when you start a project like this that they understand what they're getting and you know what you're going to give them. The next thing is a must on a project this size to work collaboratively. It's impossible to work with multiple files, and it's impossible to work as one person and still meet reasonable timescales on this kind of project. So working collaboratively within Revit is just a must on a project like this. And we find that actually using work sets and assigning geometry to different technicians is not really efficient enough for us. So actually it's not necessary. So what we do is we just keep a good level of communication up between our technicians, and we communicate a lot on the areas we're working in, the disciplines we're working in, to avoid as many clashes as possible. So we found that synchronizing our data back to the central model on a daily basis is about the best balance of minimizing issues caused by synchronization, but also maintaining a smaller model, a cleaner model every time you start a new day, basically. Which brings me to a mention about to sync without links. Keeping all the links to a low level when you synchronize and save your model will keep your model size down. So if you've got point clouds loaded in, if you've got images, if you've got CAD files, removing as many of these as possible, as well as removing any 3D views, any section views. All of this, each time you save and synchronize, will help you to keep your model size down each time you save it. And finally, I think a big part of our development and efficiency, something I would recommend, is to really develop family creation techniques. So to basically develop a large library of families of really flexible and adjustable face. And that's what we've done, and we've found that over the years, over various projects, we can now basically come at any project of any type, and we've got pretty much the families to cope with it, flexible enough to cope with it. Okay, thank you very much. I'll pass you back over to Kevin.
Okay, terrific. Thanks a lot, Phil. Appreciate that. And next, we are going to move over and talk to Siavash Mohseni of Hensel Phelps, and he's going to be discussing that healthcare facility. It's actually in the United States, so we're interested to hear about that. Siavash, you've got control.
All right. So first of all, I wanted to explain a little bit about Hensel Phelps. Hensel Phelps has been established in 1937, almost 78 years ago, and it's been in construction for a while, and been a #1 general contractor with the government, and working almost on 180 airports projects, higher educations, healthcare facilities, and name it, all kinds of construction projects. And also a project that helped us a lot to get involved with BIM, VDC, and laser scanning was one of our mega projects on the microchips production. And since that time, we spent a lot of time and money and investment to develop reality capture in our company. So if I get back to the topic we got for the healthcare facility, this one that you guys see a picture of it, it's a $750 million project. It includes 4 large buildings, 1 hospital, parking lot, and energy center, and another building that is supporting the whole area. And one of the unique pieces of this project is it's all starting from zero. So it's a brand new building that was a good challenge for laser scanning reality capture, when people were saying laser scanning is just for the existing condition, for the as-built thing, or something that you have it from the past and you don't have enough documentation for it. But we specifically been focused on this project to prove it to ourselves and other projects that we have, that we can use laser scanning on any phases of construction, from pre-construction design, then unit construction, and now also after that on the facility management and life cycle management. So on the next slide, we had some challenges that it was some unique challenges for this project. First of all, speed of that project. We are expensing almost $27 to $28 million per month, and as you can see, it's going to be lots of moving pieces, working with lots of trades, and we use laser scanning for several different phases. First, for the floor flatness and levelness reports, for the comparing cambers, for beam coordinations, for creating an as-built thing. So because of the speed of the project, if we don't follow our schedule, we could miss some options. We could miss the opportunity to scan it. For example, for the structures, if we go and be late for a few days, they're going to put the fireproofing up and running, and you cannot capture your steel structure in that thing. And also coordinate system, we decided to have all of our coordinates on the real world conditions. So our XY value were about million feet every each of them, like 1 million for X's and 6 million for Y's. And another challenge we had is none of our HP staffs over here and none of our trades or owner, they had any training on a laser scanning, how to use it, how to collaborate it with their software, and what is the benefit of laser scanning for this project. So, not sure if it is going. Okay. And on this project, we had tons of scans, almost 2,500 scans, and also because of the time problem that we have with that, we had to process it as fast as we could, and also as you guys heard from Phil, it's going to be a unique challenge when you're dealing with the big projects for managing a database. Where do you want to put it to have an access, to provide an access for everybody to have an access to it? If you put it on the server, it's tough to manage it because of those terabytes of data on the server, and also time management. What do you want to do? When do you want to scan it? Because of all of those people walking around there, everyone wants to have their job done, and so you cannot go to the field and say, hey guys, I want to put the red tape over here, you cannot come over here and work. You cannot interrupt their workflow. So it's a lot of moving pieces around there, which we had to pre-plan, and we had to work with everybody to make sure it is working. So as I said, we had 2,500 of the scans, we had 10 engineers in the scanning, and we had 330 forward scanners, and one person was in charge of the registration and creating reports. One of the big challenges over here is how to apply the coordinates to our scans. So on every levels, we had a professional surveyor come establish few points, and the rest of it, our field engineers went there and established like 30 points, 40 points per floor in order to use it for scanning registration. And because of that was like their first job, or it happens during the surveying time that you might not close your level up or whatever you guys have there. Then when we apply the coordinates to our register to scan, it was not working. So sometimes you need to go back and forth with the field people to make sure the survey point that they're providing is good enough. But main challenge was if we go put our targets out there, shoot the targets, and scan it, and check it out 3 days later and see the coordinates not working, we didn't have a chance to go back and shoot the survey point because they were doing fireproofing. That means they got rid of our targets or they cover it. So it is important to make sure all of those things is working, or surveying fine, to managing the data, and who's going to be in charge of all of those things. Trying to go to the next slide, but it seems I don't have a control on that. Kevin, can you help me?
There you go.
Okay. Oh, it seems it jumped a lot.
You want to go back one?
Yes. And one more.
One more. Okay.
Okay. So I'm good on this one. I'll go to the next one.
Okay.
Okay. So what was our workflow over there after checking all the survey points, put in the registration, and make sure everything's working, doing few steps for QCing? We had two modelers working on as-built in the building. There we got the accurate plot points, and we got a kind of accurate design model. But if you compare, when I was comparing plot points with the design model, I had deviations, and those deviations, unfortunately, they were not consistent. So sometimes you have a consistent deviation. You're going to say, I'm going to move X, Y, Z value with this amount, so my model is going to be matched with my plot points. But if you're dealing with some rotations, some angles, you might have a slight deviation on one side of the building, but you might have a huge deviation on the other side. So we decided to go and as-built the main structure part. And for this case, we use Edgewise. And I had a reason for it, because I said, I don't have experienced people. What is the easiest software that it's user-friendly software, and it's like it has a reasonable price? So we decided to use Edgewise first for these two reasons. And then for the final deliverables that we had to deliver the registered plot points, create the 3D as-built model, and provide enough training for everyone that is going to use the scan data and the model for the BIM coordination. We had to deliver floor flatness and levelness reports, and also camber reports to provide the feedbacks to our structure designers. So with all of those things, just imagine when you go to the job site that they have almost zero experience with laser scanning, a little bit with 3D modeling, in all of those things that you want to do. That was a tough one, but fortunately, with a few months of work, we could handle it. So as you can see, for Edgewise, when we used it, not only it was easy to train our staff, the price was reasonable. So when I asked for that money, nobody said no. And I had a quick test on one level of those modeling. We wanted to huge old workflow for one of those levels. It took almost 92 hours, and then we started to use Edgewise with the people with way less experience, and it was almost 54 hours, which it saved us 40% at least on that piece. And some of the things are highly recommended to you guys is pre-planning. When we want to start a project, we have to understand what is the scope, who's our end users, what kind of software they are using, what is their workflow. If you go and create a point cloud in a file format that is not usable for them, it doesn't make any sense. It has to be different options available for the end users. And phasing is one of the most, phasing and scheduling is one of the most important part of it when you deal with a big project with so many moving pieces. The second thing is every time that we go to any project, we ask for coordinates, survey points. Sometimes we can provide the surveying, but we try to avoid that piece because of the legal issue behind it. We try to accept less risk on that piece. That's why we usually want to have a professional surveyor doing that, or projects do it by themselves. Then we take over that piece and move it forward from that part. But the main problem with that is when you don't do that job with yourself, you have a QC process. You might go back and forth 3-4 times to make sure that survey points are working. The next option is creating a strong workflow. So when you understand everything's happening there with the trades, with your staff, with owner, then you need to come up with a solution. And it's not only matched with everybody's workflow, it has to comprehend what they have. It has to help them, and it has to be in a way, if in the future, next 2-3 months, someone comes to you and say, hey, additional to the deliverables that I have, or additional to the way that we are using the scan, I need to adjust what we have. So if you have a strong workflow, you can add those extra requests to your workflow. The other one is dedicated person. If you go to a big project and just say, okay, I got 10 field engineers, they are smart, but they are busy. Like I've seen them, they are working over here from 5:30 a.m. to 8 p.m. And every time that I was asking them to do something, they had so many other things to do additional to what I was asking for. So it took us a little bit of time to have everybody in the same page and say, hey, if we want to get this job done, we need to have a dedicated person on that piece. And another one is get help from experts. If people, when they touch laser scanner, when they touch 3D modeling, say, oh, it is so cool. It's like a game engine. It's like playing a video games. But it is not. It's like no matter how smart you are, no matter how much money you spend, experience is a first factor playing in this game. And having an expert by you always helping, and it's helping you to protect yourself for future failures. The other one is, which I think as a company we did a good job on that one. We have a different QC layers, and we update that QC layers as we go by the software updates, by the new things we learn. But what we do is I always ask someone else to put extra eyes on what I've done, or vice versa. So this is so important to not even missing any small errors or what we have, and using the right tools, right? I can come to this project and, for example, for the 3D modeling, I say, hey, I need 6 licenses. Every each of these licenses is going to cost me 15 grand, and I need to provide the training for them. It's going to cost $2,000 per day, and they need at least a couple of weeks of training. You will see by end of the day, you gave a huge list to the decision makers, and you are asking them to spend that much money, which maybe they don't believe that it's worth it to spend that much money. So using the right tools, for example, if you use Edgewise, because of so many reasons it is the price is reasonable, it is easy to learn, it has some option that other software they don't have it. For example, when you are dealing with the Revit model, there's nothing better than Edgewise to handle that problem. When you are dealing with the huge coordinates, Edgewise do the same things with no problem. It's like you can train. I tried it for 7 to 10 different people. You can train people with zero experience in a few hours, and in a few days they can be professional on 3D modeling. So I guess that was my part. I'm gonna give it back to Kevin.
Thank you all. Terrific. That was a great case study, Siavash. Thank you. And we can all see that there were a lot of challenges in a project like that with the large healthcare facility. And now I'm going to ask Alex Dimogenes to come on board. And Alex is going to give us a roundup of other perspectives on Big BIM from around the industry. Alex, take it away.
All right, thank you very much, Kevin. I want to say thank you to Phil and Siavash for their sharing of their case studies today, and thanks to all of you for joining us. First thing I'm going to do is let everybody know of our next release of the software, which is coming out March 30th. We're going to have Edgewise 5.0. And with the release, we've done a few things. We've done some major rewrites of the extraction algorithms for virtually eliminating false positives. So what that means to you is a lot less time spending modeling and cleaning up the software, or the model in the software. Another thing that, as Siavash alluded to, was our connection to Revit is pretty much unparalleled in the industry, and we've gone even further, allowing for more elbows, all elbows in fact, and other elements to transfer over into Revit. So that's something to look forward to. The third thing is that we've integrated with Plant 3D for extracting intelligent models into Plant 3D, which is great for all you Plant 3D users. And the final is the bubble view visualization. So we're going to have a higher degree of higher definition visualization for the point cloud, and you can model from that perspective. So it's a lot easier to use than just modeling from the point cloud. With that, what are the 3 to 5 most important things a firm must consider when doing their first very large as-built BIM project? So we've polled the industry. We've put some questions out there into LinkedIn and the laser scanning forum as well. Gotten some great feedback. So first thing I'm going to do, kind of as a roundup, what I heard a lot from Siavash and Phil, kind of made me think of a few things. So 3 things: consistency, communication, and collaboration. And with that, one is fully understanding the scope of work. So what Keith McKinney here is saying is, it's important to work with the client, not take for granted what they understand as far as the process of scanning, registering, and modeling goes. Really, educate them on what that process is, listen to them and understand what they need, and making sure that you're paying very close attention to tolerances and level of detail as far as what's required. Otherwise, the budget can quickly get out of hand. The second is ensure that level of detail is communicated to your team. So again, communication is very important when you're dealing with any project, but especially with large projects such as these. So understanding, what you're going to use the software for, how you're going to use it, make sure that the staff is well trained, and select software that's easy to learn and covers all your modeling needs in those specific disciplines. Number 3 was clearly communicating the deliverables to the client. So again, communication is very clear. Are you delivering 2D plans, section analysis, et cetera, or a full 3D model? Second up here is some points from Mark Hanna at Precision Point. Again, another thing with large projects is it's very critical to have an established grid of survey points, survey network throughout the project. That's important for the coordinate system that you're going to be using. The second is creating a field execution plan. So again, understanding how you're going to use your multiple disciplines, the different crews, how many scanners you're going to be using, and avoid some redundancy and potential voids in the scan data. So knowing where your crews are going to be broken down into each segment. And the third one was georeferencing the point cloud to a real-world coordinate system. So it's better managing of the downstream point cloud modeling workflows when you are assigned to a real-world coordinate system, basically tying in the different disciplines to work on the same coordinate system. So Kelly Cohn from the Beck Group, he provided us with some good insights as well. So again, he's saying, for sure use a survey control network. If you don't have control over how the data is collected in the field, then this can lead to some problems down the road. So it's very important to have a very tight registration and a coordinate system on the cloud, the point cloud. Excuse me. And he also suggests using the same coordinate system for the project. So what he's saying there is that if you're not using the same coordinate system throughout the project, it's possible that you'll have to go through manual alignment of the data down the road, and this can lead to some inconsistencies or definitely increasing the time it takes to coordinate the data. So that's very important. And another one is establishing consistent templates and content so that everybody in the project is using the same basis standards for the information. And finally, we had some tips from Greg Hale. Again, this is a good one for going back to that collaboration, is don't go at it alone. It's quite a bit different to go from maybe a 10,000 square foot mechanical room to a hospital, right? So if it's your first time doing a large BIM project, don't do it by yourself. Find some people with experience, with these projects, hire them to mentor you through the process. And don't feel like you have to be out there as an island and suffer through the mistakes that come with that. The second is do a hardware software audit. So again, understand what kind of equipment you need to use, what kind of software you're going to be using. That's very important for getting the right deliverables for your client. And third, divide to conquer. So again, it's reducing the project into smaller segments by scope or work by area, and this allows the project to be viewed and worked on by various participants in smaller sizes. So breaking it down rather than trying to manage the entire project in one file, so to speak. So those are all really really important. We've got there's some more information on the laser scanning forum, some other really good comments that people have made. If you are on there, we'd love to have you go check that out as well.
All right, terrific, Alex. We appreciate that. And we are ready for the Q&A session. And so what I'll ask again is for the attendees. We've actually already had quite a few questions come in, and but we have plenty of time to take more. And I'm going to start us off here in just a second. So go ahead, type your questions in there to the question window. And I'm going to ask the experts to turn their mics back on. And looks like the first question, Phil, is going to go to you. What is Bury's preferred file storage method for data which has high sensitivity, a secure environment where encryption and permissions are strictly controlled? Have you dealt with that, Phil?
Okay. I mean, we keep all of our data on a central server. We pretty rarely work on anything remotely anyway, so security isn't too much of an issue. We've got our own security backup systems and very secure backup systems, but in terms of working remotely and people accessing that data, we just keep it all pretty central to our office, basically.
Okay, all right. And someone asked, they were curious about the 1,500 scans you had, Phil. They asked, what software did you use to connect all those up, to register them?
We use Scene, the latest Scene for that, Faris Scene, all connected off a full survey control network. So those survey references were brought into various different Scene models, but everything was done within Faris Scene, the full registration.
Okay, great. And it looks like there was some interest here. You talked about those ceiling tiles, which you mentioned a lot of the MEP was above those ceiling tiles. Can you elaborate a little bit on how you did capture the scans up there? Assuming this person says we assume you removed the ceiling tiles.
Yeah, the ceiling tiles were actually removed by an on-site contractor rather than ourselves. But we worked a number of methods depending on the height of the ceilings. I'm probably not the best person to speak to about it because I wasn't on site myself, but I believe they used a mixture of, we've got some extendable tripods to lift up to various different heights, and I think they even used a kind of scissor lift type structure and scaffolding to get to that height, and basically went up in various different places to try and access that, you know, in various different positions without having to remove the entire ceiling.
Right. And it's kind of interesting. You do mention that you had a third party remove those tiles. Was that a liability issue? I mean, did you prefer not to have to touch them, or was it actually the university that says, hey, you know, we're going to have our own folks remove those?
Yeah, we decided that partly on a kind of they had a lot of asbestos survey going on at the time, and it just kind of took our liability away from that. But also just from a kind of safety, and you know, we wouldn't want any of our guys damaging anything. It just left it all in their hands, and it was just the way we decided to work on this project, so that we're not involving ourselves in any intrusive works, basically.
Right. Right. Okay. All right. The next question is for Siavash. This is interesting. This person is interested in the fact that you're working on a live construction site, and they were wondering if dust and dirt was a problem, and I assume they mean in the scanning part of the project.
Yeah, we didn't have that problem in this project because this project is in California and we got a nice weather down here. But we had some projects that we were dealing with dust, with snow, with rain. It's always important to understand the environment. For sure, when you are dealing with dust and heavy dust and snow, it is not feasible to use normal laser scanners, but we didn't have that problem over here. And but I've seen some scan data from other projects that does kind of ruin some of the scans. And the only things you can do is change your shifts. If they are working on days, usually from 7 a.m. to 4 p.m., we had a night crew going from 4 p.m. to 1 a.m. and get the job done and avoid any confliction with others.
Okay, very good. All right, and somebody asked Siavash, how did the model integrate with Tekla structures?
We didn't use Tekla in this project, but one thing I would recommend is, it was part of the piece I said, is we deliver everything based on the end user's needs. In this project, end user, they just wanted to have a Revit model. But we were dealing with the project that they wanted to have an ecosystem building designers model, or they wanted to have a ArchiCAD. And for Tekla, it depends on the owner, but we did not use it on this project.
Okay, all right, fair enough. And Phil, this one's for you. What IFC data extraction tool or method did you employ?
Well, actually, for this one, although we use the native export within Revit, so there's actually there is a tool you can download to basically export direct to ArchiCAD. But actually, client for this project, they were pretty experienced and they had their own copies of Revit in their office, and they did most of that translation themselves with any issues. But although we did issue an IFC initially, basically from that native export along with the Revit file, and we didn't seem to have too many issues with that. But we kind of left it in their hands beyond that point.
Okay, all right. And this one, I'm going to ask both Phil and Siavash to weigh in on this. And actually, Alex, if you have something to say as well, how do you feel about scanning large projects targetless? unless you're tying into survey control points, or do you suggest using targets between every scan? Phil, why don't you take that first?
I think to tie in with your survey control, you need some kind of target registration, I think, and certainly on larger projects to have that overall control, to control your your clusters of scans. But I think, as you know, I kind of treat it as the scan targets give you a bit of a fallback, whatever happens. But yeah, I do agree that within those groups of scans, actually, if you can cluster and you can group them and register them targetless, you do actually get finer results and you get cleaner data. But I think some form of target control to control the overall registration is kind of a must, really.
Okay, Siavash, what do you think about that one?
I would say it depends on which system for laser scanning and which software you are using. It's so dependent on that specific software. I heard a lot that people have been saying targetless registration will save a lot of time. Actually, it is not doing it because we own all existing registration licenses for laser scanning, and we know how to use all of those. But I can say if you either need to have really experienced people to do that, and sometimes they might have a problem that you cannot fix that problem without your targets. So I always rely on targets, and I always like to have a targets because it depends on which kind of laser scanner you are using. As soon as you get far from the point that you start scanning, you're going to lose your accuracy. The only thing that can tie back everything together is to have, for example, 4 or 5 targets like every 50 feet. And because you're going to tie those targets back to the survey point, right? And that means every 50 feet, you're going to have registered scans to that area, and they are good to go with each other. And we had some project, we said, oh, we're going to do it targetless, or we're going to do it without surveying. From the point that we started, we went to the other side of the building, and the scans, they were almost 1 foot off to 2 foot off. So I highly recommend to, even if you want to do it targetless, do it mix and match with targets for sure.
Okay, great. Alex, do you have anything to add on that one?
Yeah, I tend to agree with Siavash and Phil. I mean, there is some dependence on the type of scanning and also maybe the project that you're using, but mostly the survey targets are important for establishing that overall global network for your coordinate system and tying the data down, but also having the targets both as a fallback and as a way to ensure that as you're going through, the data is registered accurately. Is pretty critical. I think that some of the targetless registration is great for certain projects, smaller projects in some areas, but when you deal with these really large-scale projects, my thought is better to have that extra level of security with the targets and redundancy, just in case you do have to go back and reestablish a network of coordinates.
Okay, very good. And Phil, somebody wants to know what size is a manageable Revit file size, and what do you do when Revit synchronization fails?
Okay, well, I mean, I think the size of the file is pretty sort of piece to string. It's all dependent on the power of your computer, really. I think. I mean, we, on a smaller survey to BIM project, maybe a small office block or something like that, we'd try and keep it under. It really depends on the size of the building, but maybe under 50 meg, under 30 meg, we really sort of purge that file out for the end user. But when we're working in projects, we work in a Revit file with links, and it's up to 2 gig. And so in our office, that's usable. But maybe in other offices where people are generally working on 2D plans up until this point, they wouldn't have the power to deal with that. Sorry, what was the second part of the question?
It was what do you do if the Revit synchronization fails? Did you encounter that?
Yeah, a lot of the time, to be honest with you, it's kind of have its own little inbuilt sort of bugs and things like that. And we've struggled a lot of the time to find out what the reason is for it. It seems to be during the synchronization. It's very rarely that somebody clashes because it's got a quite sophisticated log system to stop you taking control of anybody else's geometry. It seems to be like when you synchronize, if it thinks there's an element, it's quite hard to explain, but if you've maybe loaded a family in to a project and you synchronize with somebody else who hasn't got that family in that project, it can throw up a few issues because it tries to take it across and it doesn't exist. But usually a quick way of solving these problems seems to be either a copy and paste of those elements that it throws up errors with out of the project, resync, bring them back in again, and usually it solves the issues.
Okay, all right. And Alex, here's one question for you. How does Edgewise work around areas of extremely congested facilities? And what are the issues and workarounds that you face there?
That's a good question. Yeah, so I mean, the way that our algorithms are working, especially for the automated extraction of the piping, really we're looking for anything that's got a cylindrical shape to it. So even in very highly congested areas, as long as there's enough coverage on the pipes, we're able to extract those very well. And then with the structure, again, it's a little bit similar. Now that's not as fully automated of a process, but as long as there's enough line of sight to those objects that you need to extract, the software works very well. And we've also got some new clipping boxes and things like that to isolate areas that you need to focus specifically on that where you're modeling in a specific section.
Okay. All right, great. We're getting a lot of questions about targets. Here's another one. Siavash, let me ask you first. Did you use spheres with prism casts in your targets?
Not for this project. You don't need to necessarily get those expensive targets or spheres. Mm-hmm. They're going to be useful sometimes. Depends again back to which kind of a scanner you're using. But with all improvement on Leica, ZNF, and Fluoro scanners happen, you can use mix and match of black and white targets, which you just need to go and print it out. And the spheres, you can just create your own spheres without prism and save a lot of time and money on that piece. Those spheres with the texture they put it on it and with the device they put it inside, it will help for your registration. But when you're dealing with a large project, you are not be able to go and purchase like 500 of those skins. That's the amount of like spheres that we technically using in our big project. So we cannot afford to go spend 300, 400 per spheres. That's why we had to go and find a way to go a cheaper way, but still having a good quality.
Right, right. And Phil, how about you? Any experience with the spheres?
I would tend to sort of generally agree with Siavash there. I mean, we don't use the spheres with the prism targets. Again, for sort of economy and practical reasons, we tend to use the checkerboard targets to control in from the survey data and then use a mixture of the spheres we've got with other checkerboards.
Okay, great. And it looks like this will be our last question. Again, it's about, targeting. What is the best practice for control points? Do you have them 10 feet apart, 20 feet apart, or 50 feet apart, etc.? Phil, why don't you take it first, and then Siavash, why don't you wrap it up?
I think it depends on the project, really. I mean, if you're talking about a large area of scans, then actually it's more important that you've got that survey control in different areas of your cluster, so that the overall position of your cluster is more accurate, rather than actually having your spheres or targets a certain distance apart from each other. And again, it depends on the settings on your scanner, depending on the project. So it's pretty dependent, really.
Okay, Siavash, anything else on that one?
Yeah, I would say it depends on what is the purpose of using those scans and what kind of accuracy we are looking for. If you are looking for creating a floor flatness and levelness, for sure your accuracy has to be as high as you can. Or if you're dealing with the area, small area with bunch of pipes and new design and demolition is going on all over the place, and everything needs to be accurate by 1/8 of an inch, even you have to go with more targets and closer to each other. But for the general comment, I would say it's better if I have a like a floor. I would divide that floor to 5 different areas, and in every 5 different areas, I would establish 4 to 5 survey points for that specific area. And again, it's getting back to how big is the area or how far is the things. But I'm just talking about manageable floor. I would divide it to 4 or 5 different areas. And when I'm establishing 4 or 5 coordinates, I put those black and white targets or my permanent targets close to each other, because you're always going to have a chance to go and have a quick QC for 5-6 scans with those targets. That means you don't need to register all the scans together, apply the coordinates, and say, oh, it's not working, or where's my accuracy? But when you have it close to each other, you can quickly save some time on that piece.
Okay, terrific. That'll be the last word, Siavash, because I'm afraid we're out of time. And so on behalf of our panelists, Phil, Siavash, and Alex, and our sponsors, Workflow 4.0 and ClearEdge 3D, let me thank you and our audience for joining us today. And as a reminder, you will be receiving an email after the broadcast with a link to the recording. There'll be a chance to subscribe to our newsletter, and there'll be some other follow-up information. So we hope to see you again for our next webinar. Thanks for joining us.